Okay, in this presentation we are going to look at random variables. In particular, what we're going to do is look at an introductory question that helps us get used to some of the key concepts and key statistical identities, mathematical identities that we're going to be using on an ongoing basis. So let x be the random variable representing the cost of maintaining a car. Suppose that the expected value of x is 200, e of x equals 200, and that the variance of x is 260. So if a tax of 20% is introduced on all items associated with the maintenance of the car, what is the variance of the cost of maintaining the car going to be? Okay, so essentially this will make us rely on lots of the key identities associated with random variables. Specifically, it's actually these ones here. Okay, and so this is essentially all the stuff you have to learn when dealing with random variables, both combinations of random variables and just transformations of random variables. But essentially what we're going to do is rely on these two. Actually, specifically the second one of those two, the variance of ax plus b equals a squared times the variance of x. Okay, so the solution, the new cost of maintaining the car is 1.2x. Okay, so essentially all the costs go up by 20% across the board. So it's a consistent for everyone, no matter what the average cost is, 20% for everyone. So the new cost of maintaining the car is 1.2x. Okay, so the variance of maintaining the car is variance of 1.2x, which is 1.2 squared. That should be square there, times the variance of x. That is 1.44 times 260, and that is 374. So we can calculate the standard deviation of x to be the square root of the variance. I'm not going to do that really because I just decided to chop that out, but essentially if you want the standard deviation of x, it's simply the square root of 374. The new mean is going to be 240. Okay, so the new expected value is 240. Not that we're asked that either, but just for the sake of completion. Okay, so key thing there really was that we don't really use b when we're looking at the variance, okay, the b term, but it will come up here if we're recalculating the new expected value of a linear transformation of x. But for b it wouldn't come up, but we would see a, and in fact we would see it squared. Okay, that's it really. We'll leave it there.